Welcome everyone. Thanks for joining us today for this FieldView Basics webinar. Whether you're brand new or just looking for a refresher, this session will walk you through everything you need to get comfortable with in FieldView. I'm excited to take you through the essential tools and features of FieldView that will help you create great visualizations and extract engineering insights efficiently. My name is Jerome Nelson. I will be your presenter today, along with my colleague Gibson Adams. We are both part of the Tecplot technical support group. To give you a very short history of FieldView, it was first developed by a company called Intelligent Light over 25 years ago. FieldView joined the Tecplot family of products in October 2019. It was acquired by the company Vela. It's now under Tecplot Inc., which includes a suite of other products such as Tecplot 360, Tecplot Chorus, Tecplot RS, and of course, FieldView. Today, we will focus on a few demos that would teach you how to quickly and easily create high-quality images and videos. We'll touch on how to analyze large simulation results with Parallel and FieldView, and we will try to get to additional features such as scripting, client-server, extracts, and advanced animations. So without further ado, let's start. So let's go back here. Let's begin our presentation by loading a sample dataset. So we'll go to File and select Data Input. And you can select your format and you can select the read grid or combine data. For time-saving purposes, I've already preloaded my data. So I'm using a sample dataset of a car. By default, FieldView will open the data in serial mode. If you plan to work with larger datasets or want better performance, I'll show you later how to enable parallel processing. So I'll close that. So once the data is loaded, FieldView initially displays the outline of the blocks that make up the grid that we are working with. We can remove this by deselecting the boundary box with this icon right here. So I'll remove that. And next, we'll want to create some objects. All these objects are listed here in the vertical toolbar on the left. They contain such objects such as ISO surfaces, coordinate surfaces, boundary boxes, etc. And these options are also available in the Visualization Panels tab up here. The first object we're going to create are boundary surfaces. So to do this, we'll go over to this boundary surface icon, and then we will click it to bring up the boundary surface menu, and then we will click Create to begin the process. You'll notice that a list of all the boundary surfaces from the solver appears here. We can use the filter box to quickly search for specific surfaces. For example, if I'm only interested in the CFD boundaries, I'll type in CFD to filter out all the rest of the unwanted surfaces. This feature is especially useful when you have a large list of surfaces. So next, I'd like to group like surfaces together by creating multiple surfaces. And I can do this by highlighting these first two boundaries. These are the front and rear wheels. So I'll select these and then hit OK to create my first set of surfaces. And I will do that for the rest of the surfaces. I'll hit Create, and then 9 and 10 are the side mirrors in the body, and then hit OK. Create. 11 is the exhaust. Select OK, and then create again. And finally, 12 is the underbody. And then select OK. So now that we have all the surfaces created, next we can center this image using this icon right here. This is to center the image. So we can get like a better view of our orientation. And we could even further enhance this we can go to this icon right here, which is the Define Views tab. And I can select, for example, -X to bring it flat, and then I could just rotate it to kind of get it to the angle that I want. And then we can zoom in a little bit more. And I'll close this. So next, we'll select the display type up here, and we'll switch it from a mesh view to smooth shaded view for a cleaner presentation. So I've only changed this display type to just a subset of these boundary surfaces. We can use this unify button, and when we click this, this will apply the settings to the rest of the surfaces. So we click that, and now we have a smooth view of our call all around. So next, we'll want to look at the variables in our geometry. We'll want to change our coloring over here from geometric to scalar. And then we will come down here and select the scalar button. And we can choose which variable or function we would like to color our surface by. We'll start with selecting pressure right here, and then we will select calculate. And once again, we can use the unify button to apply these settings to the rest of the surfaces. So sometimes pressure can be hard to visualize with the default color map, which is spectrum. So we can select the color map tab and adjust the min and max values for a better color representation. I'll just select local, which will automatically do some of this for you. Depending on your data, spectrum could be a bad selection for showing all the differences in your model. You have the option to change the color map using this drop-down menu. A quick pro tip is colors such as achromatic vision or infernal or plasma. These are a good selection of divergent maps with luminance variations that highlight mid-range nuances better than others. So now that we have our surfaces colored by our pressure scalar, we want to understand what these colors correspond to. So next, we will add a legend. So you'll click on this legend tab, and you can select show legend. You have other options right here. You can switch to a horizontal orientation if your layout favors top or bottom space. So I'll click on horizontal. And down here, you can see this green box, which is text only. And it's telling us that we can use Shift plus left click to move the label and Shift plus right click to resize the label. So what I'll do is I'll Shift and left click and move it down here. And then I'll right click to resize it. And I can adjust the number of labels right here. So I'll change it from 2 to 5. And as you can see, we also have the ability to adjust a number of other options in here. But for now, I'll say that I'm satisfied with this image. So now that we're done adjusting this model, what if we want to put this into your presentation, or how do we save this? One thing that you can do is you can copy it. So you can go to Edit, Copy, and then select Graphics. And then what you could come do is you could come down into your presentation, right click, and paste. And now we have our image pasted into our presentation. Another option is we can save this image. We can save the image as a file. And to do that, we can go to File, Save Image, and then select Graphics. And we can choose what format we want, with the default being PNG. So, I can just save that as webinar example, and then hit save. So now that it's saved, we can easily share this image with colleagues, or we can insert it into other documents. Now, before we move on, I also want to show you how to save your results by using a feature called a restart. So you can do this by going to File and selecting save restart. And we'll choose a complete restart, and then we'll just save it as webinar. And once you save it, what this does is this allows us to back up our session at a later time if desired, or allows you to apply saved objects or settings of the workflow to different data sets. So at this point, we have just shown how FieldView excels at how easy and quick it is to make quality images that can be used for your professional and/or academic purposes. So now that we've seen how boundary surfaces and color maps give us a big picture view, let's cut into the data itself. FieldView makes it easy to slice through the full field and animate those planes to see how properties evolve spatially using cutting planes or coordinate surfaces. So let's start by just resimplifying this view. So I remove the legend, I'll go back to the surface, I'll switch it back to geometric scaling, and then once again, we'll use the Snootify button to apply that to all surfaces. So now we're kind of back at our kind of like default image. So let's, so we'll start with selecting a coordinate surface right here, this menu. We'll select this coordinate surface object, and then we will select create to add a new plane. So you can kind of see, I'll zoom out a little bit since it's a little bit bigger. And we can select the display type, and we will select this and change it to constant. So down here, we can move or rotate this plane interactively using the slider. So you can see I'm moving it. But for precision, I'll show you how to lock it to its exact location. And you can do this by simply going to current and then typing in a value. I'll enter 2.5 and then hit enter. I'll zoom out a little bit more. Next, we'll want to apply scalar coloring. And so I'll go to scalar, or I'll go to coloring, and then I'll select a scalar. And next, we'll want to choose the variable that we want to color this by. So I'll click this button, and the variable I'm interested in right now is looking at velocity magnitude. If you look in this list, you can see that this variable doesn't exist. So I'm going to demonstrate to you how to create variables or functions quickly. So I'll close this out, and you can click on the function icon, which is this function right here. So let's select this, and then we'll click create. So we already have a pre-made operation for magnitude. So we can simply select magnitude, and then we can go down into our variable list and select velocity. Oops, I did it twice. Just need it once. Select our close parentheses, and then hit OK. So at this menu, you can either enter a name manually for your formula, or you could just use the formula name. For now, it's a simple formula, so I'll just use the formula as the name. So we can close this box. And now when I go back to scalar to select my variable, you'll see the newly created velocity magnitude at the bottom. So I'll select that and then select calculate. So far with our settings, we have our color maps, the default, which is spectrum. We have our display type at constant. I'll go to my color map, and like I did in the previous example, I'll select local to have that locally, the min and max values locally adjusted. And then I'll go back on the main surface tab, and down here in this chord plane section, you can see that it's easy to change the axis of our plane from X to Y to Z. So if we're in X, I can select Y, and then I can select Z. So I'll go back to X. We can also reduce the size of our plane to better fit our model by using the slider down here, these Y clip and Z clip, or we can enter the values manually. So since I kind of want a more reasonable size for this cut plane, I'll just type, I know that -2 works well. So I'll just type in -2 for the min, 2 for the max. And then again for Z clip, I know that 1.5 is a good value. And zoom this in to get a better view. We can also apply some transparency so the rest of the body model is visible through this plane. So over here in transparency, I can select a value and I think we'll settle on 37.5%. Next, I'll adjust the min and max values or the max positions of the plane to limit it to the car body using the slider. So for example, I can slide this to the front of the vehicle, and then I can grab this min box and set the min right there. And then I can go to the back of the vehicle. Oops, a little bit too far. And then I can set the max there. And also I'll go back to my 2.5 starting value. And then I'll come over here and then I'll set the steps to 100. So when we do end up sweeping this plane, it won't move too quickly. So now that we have this set up, we can sweep the location of the plane to see it animate from front to back and see how velocity magnitude changes as the location of the plane changes. I have to apologize that the sweeping motion may not be as smooth when watching through the webinar, but if you do this on your own machine or save a video, you should be presented with a smooth motion. So I'll stop this sweep. And I'll go back to 2.5. So now that we've just shown the sweep animation, what if we want to turn this into a video? We can do this by going to Tools and going down to Flipbook Build Mode, which is our name for the simplest video that you can do. So if I click on this, pay attention to this sweep button over here. If I click on Sweep Build Mode, we'll just acknowledge that warning. You'll notice that the sweep button becomes the build button. And what I'll do is I'll change the steps to 25 just for time saving purposes. So now when I click build, it's going to loop through all the steps, which will be cached into memory. And when it's done, we can save a video with the default being MP4, right? We also can control frame rate, playback speed, etc. So I'll close this. Yeah, I'll acknowledge that. So at this point, we have now shown you how you can make both images and animations within FieldView. So next, let's look at the flow fields of multiple planes at different locations on the body simultaneously. You can do this by simply clicking the Create button to create more surfaces, and then you can just adjust the locations using the slider. So I just created a second one. I'll move it toward the front, and I'll hit Create again. Use the third one, or create a third one, and I'll move it toward the rear. And to kind of get a better view, I can just rotate this a little bit more. And then now you can see all of our planes. And so now that I've shown you how to do this, let's get rid of these surfaces by deleting them. I'd like to mention that there's a feature that you can use it's called Quick Pick, which is done by just double clicking on the surface of interest, and that will select it, and then you can delete that. So if I double click back here, I just selected that surface, I hit delete, and double click here, quick pick that, and delete, and now we're back at the beginning. So really quick, let me just change these steps back to 100. And what I'm going to do next is I'm just going to create another surface for the next example. And notice that when I created this additional surface, notice that all the properties get applied to the new object. So the new object or new surface, it inherits all of the surface properties from the first object. So I want to show you an example of another way to get a different view of multiple cut planes in the same window. So I'll start by zooming out of this a little bit, and then I'll just move this over here a little bit down to the bottom left. So we can isolate that surface that we just created. And we can do this by going up to this object and changing from world to surface. And now what I can do is I can grab this and then move this surface off the car. And I want to put this, I want to make this flat to the screen. So what I can do is I can go to this Define Views icon and select this, and then I can select -X to make it flat, and then I can select Detach, which will detach it from all under transforms. And since it's detached from the world, you may notice that I'll have to readjust this because I have to readjust this back to its previous position since it's detached. So what I can do is I can grab this, move this back up, or I'll zoom out a little bit, and then I can use this transforms button, and then I can just hit this rotate to kind of rotate it in a little bit more precise way. And then I'll go back to here. So now that we have it, now we have it flat to the screen. So now that's back where I want it, we can go back and select world or select surface and change it back to world. And we can change the view of the rest of the world without affecting that other surface since it's detached. So what I can do is I can rotate this back again how I had it last time. So now that we have the image set up the way that we want, I want to show you how to animate both surfaces together. We can do this by using a feature called Linked Surface Sweep. And you can do this by going to Tools and selecting Linked Surface Sweep. And now going to sweep it. And now you'll see that both planes are linked and sweeping at the same time. So this now allows me to see what is happening with the coordinate surface from a different angle as I see its location sweep across the model's body at the same time. So I'll stop this sweep and I'll delete the surface. And let's see, once again, I'll bring this back to where it had it at 2.5, and then I'll hit the center button just to center it back, and then we can zoom back in. So at this point, we've seen how to build boundary surfaces and add cut planes, but often we need to compare views side by side or manage multiple visualizations at once. FieldView makes this easy with multi-window layouts and surface linking. So if you go to these icons right here, you can see that you can split these windows either horizontally or vertically. And we'll talk about each option as we demonstrate this. But if I click here, you'll just see empty is self-explanatory. It just creates an empty window that later on we'll be able to append data to. So we will start with splitting this window vertically, and I'll choose instance. And what this does is it gives us the same object in both graphics windows. And an instance is a view-only representation of the original, and it's most useful for showing your model from different views. So if I adjust this slice position, you'll see that it adjusts in both at the same time together. Now, if I go down here and I unhighlight this world transform icon, now I can control each window's view separately. So if I want to get this image down here with the front facing flat to the screen, I can go again to this defined, quickly I can go to this defined views dialog and select -X, and now I've just changed its view. without affecting the other. And we'll do another split instance, this time in the horizontal direction. And we'll get a top-down view. So if I go here and if I choose plus Y, and to make this this image a little bit more interesting, we can create another surface, and then we can choose the Z direction or the Z plane, and then we can adjust it down here. And so now I've just created an image with multiple views of cut planes that you can copy and or save. And with these windows open, you can grab here and you can stretch them. So if you grab here, you can click and grab or click and drag, stretch them. You can choose a menu to maximize it. You can restore it. And of course, you can delete. So I can delete these two windows and I can delete this additional plane. And now I am back to my original surface. What I'll do is I'll make this not visible by clicking here. Instead of deleting the surface, I'll just make it not visible so it's easy for us to come back to later. So as you can see, splitting windows lets us compare multiple different perspectives or multiple different visualization techniques at the same time. So far, we've been working with surfaces and slices, but FieldView also has powerful ways to visualize other three-dimensional flow structures like isosurfaces and vortex identification functions. Let's take a look at those next. We'll start with creating an isosurface. We'll go over to this isosurface icon to bring up the menu, and we'll select create. We will select define iso function, and we will pick Q criterion, and then select calculate. And so while this is calculating, what we'll want to do is we'll want to change our display type from well, I think right now it's constant. So we want to change it to smooth. And we'll also want to change our coloring from a geometric gray to geometric red. And also notice here, let's change it to red really quickly. And also notice down in this area right here, you'll see that we have a very high number or high value for Q criterion. So in order to get a good view, a good technique is to kind of start at a higher value and reduce it by orders of magnitude until we find a good point. I already know that 2000 is a good starting point to see good vertical structures, so I'll just enter that here. And we can also adjust the transparency to get a better view of the model behind. And what I'll do is, when this is done, I will change the transparency to 50%. We'll see if that applies. So yeah, and let me kind of do that and zoom in a little bit so you can get a good view of that. So at this point, what if we want to view another iso surface along with this one simultaneously? We can do this by adding another window. So we can go back to this window, we'll split it vertically again, but this time we'll select copy. And by selecting copy, what this does is it creates an actual virtual copy of the dataset in a new window, which will allow you to independently display different attributes than the original. So, and once this is done copying, in the bottom window, I'll want to look at an isosurface of a different variable. And this may take a little bit longer. Hosting the go-to meeting uses additional resources, so sometimes it might increase the loading time. So once again, if you do this on your computer, it will happen quicker. So I'll zoom in here really quickly. And so yeah, to get back, we're in this window, and we will, what we would do is we will select scalar, and this time we'll want to look at vorticity and select calculate. And we'll have all the same settings, so display type, geometric coloring, transparency, that's already set from the copy. And we'll want to use the same technique for finding a good value as we did in QCriterion down here with these values. Oh, sorry, I chose vector. I meant to choose isosurface and then select vorticity. Or I chose. So now that we're back here, and yeah, so we're going to use that same technique where we have this value, it's a higher value. Again, I already know what a good value is. It's 100, so I'll enter 100. And then now we'll be able to see our model. We'll see the vorticity displayed on our model. And once again, if while keeping these world transform icons highlighted, we can, zoom in and move the image, and you'll see them both happen at both times in both windows. So this concludes how to create isosurfaces using multi-windows and the copy feature. So I'll delete this extra window, and then I can zoom out. And what I can do is I can do what I did before, is if I don't want to delete this, I can just hide this. So I can come back to it later. And then here, I'll recenter my model. And so now we're back again to our kind of stock photo. So when we create boundary surfaces, FieldView also gives us a third powerful way to visualize specific regions of the geometry. We have a rendering mode called material, and depending on the selected material, you will get different effects that replicates the visual properties of these available materials. So right now, I'll go back to the boundary surface panel, and what I'll do is I'll do a quick pick by double clicking on the body. So now I have the body selected, and then I'll go down here, and then I will select coloring by material. And what I'll do is I'll just go up here and hit the unify button really quickly, so that this material selection is already pre-selected for all of the other surfaces. So now when I go over here to materials tab and I click on it, we see a list of available materials and can start to apply these materials to each surface group. So I have the body selected already, and I can choose a glossy paint. I can select the color wheel. I can select the blue color. I can quick pick the wheels by double clicking, and then I can give it rubber. If I go up to just define views dialog, I can select -Y to get to the bottom of this car, and I can double click on the exhaust and give it a titanium. And then I can double click on the body and choose like a dull plastic. And then we can kind of give it like a lighter, or kind of like a darkish gray color. Or here, let me just to make it not blend in so much with the wheels. And I can go back to this defined views again and kind of select that and kind of rotate it to kind of get it back to where it was beforehand. And while I'm doing that, there's another quick trick, is with my complete save, it also resaves a view, or with my complete restart, it also saves a view restart. And so I could actually do that by going to File, Open, Restart. And then in this menu, I can go all the way down to View. And now when I click that, it will save and jump back to the view that I had from my previous restart. So that's kind of a quick way to get back to your view if you want to have like a default view that you like. So I'll zoom back in really quick a little bit. So we also have an environment map used for reflections, which you can change. So if you go to View and go to Background / Environment, and now we can go down to Environment, and we can select environment that's more suited, or that's better suited for a car or vehicle, and this will help with the reflections and whatnot. So right now I have it set for street and closed. So now if I zoom in, you can see the street reflection like on the side mirror. If I go back, another kind of quick tip is you can easily change the center of rotation on this vehicle too. So I can do this by going to View and selecting Center of Rotation. And now when I Control and left click, I've just made the front bumper area of the car the new center of rotation. So now when I rotate it, you'll see that it rotates about this point. And you can see how the reflections change with it as well. And you can also cancel the center of rotation by just clicking on the center icon right here. And this cancels your previous selected center rotation and recenters the image. So I'll just use my restart really quick to kind of get back to my view that I liked before. And I'm back here. And I'll close this. So this completes the more realistic materials rendering demo. And by the way, the material rendering and environment maps may look different in my version of FieldView compared to the current release or the release that you may be using. And this is because I'm using a preview version of FieldView with the reworked graphics engine that has greatly improved its visuals and performance. And this version of FieldView will be releasing next month. So what I'll do next is I'll just go back and again set my my model back to the geometric shading that I like. So I'll select that. I'm gonna hit the unify button again to kind of get back. And then what I'll do right now is I'll just save another quick restart, and I'll make sure I have to save it as a complete. So I'll save this. So this will save, the ISO surfaces and the materials that we just did. And so I'll have this saved so I can come back to this later. So far, everything that we've done in FieldView has been running on a single process. But when you're working with large CFD datasets, performance becomes critical. And that's where FieldView's parallel processing mode comes in. So yeah, everything up to this point, we've been reading the data has been with the default settings. So if I go to data input, which is serial. So let's reread this case in parallel. And you can do this by going and select local parallel. And I'll select read the grid. And then I'll select my grid. And let's see, I'll bring in the task manager. And hopefully you should probably be able to see a spike in multiple CPUs as it's loading. And FYI, our licenses give you access up to 8 cores for MPI. If you have more cores available and want more speed, we do have additional licensing options to take advantage of that. So let me move this out. And while it's loading, and we are replacing the data, you do have the option so you can replace or append your data. And so this is done loading. And now we just have our data reloaded. So now what if I want to reload the rest of my data objects or settings? right? So I can do that by going to File, and I can open a restart. And down in this menu, I can select a complete restart with no data read. Since the data is already loaded, I don't need to make another selection. So I'll select that, and then I'll select the webinar. And so if I do a complete restart, it will load all of the data serially and reapply all of the objects. But with a no data restart, we're just getting back the objects and the settings, thus saving time. And this process is still using all the CPUs. We are still getting multi-threading for the calculations or objects that benefit from it. So we are getting a sort of hybrid parallelization. It's highly encouraged to always use parallel when you can, because more often than not, you'll benefit from it. And in this demo, we've only covered local parallel, but you do have the option to use a server in instances when your data is sitting at another system and want to use multiple cores in that system for reading your data. For example, if you were using an HPC cluster. We do have documentation to explain how to do that. You can always contact support for any additional inquiries. So let's go back to our coordinate surfaces. So I'll go over to coordinate surface and click here. And let's just remake this visible again. And here I'll center this to kind of get the full, and then I'll zoom in here. So I want to show you another feature where we can export these objects to another format called XDB, which is a compact extract of your CFD data. You can do this by going to Tools and Viewer XDB Write, and I'll just name it Webinar. I'll just replace that. And for the variables that we're interested in, I'll just select velocity, and then I'll select maintain threshold surfaces, and then select OK. And yes. So just some quick background information on this model that we're using. This data is approximately, or a little bit over 2 million nodes and a little bit over 1.1 million elements. And it comes in at about a size of 440 megabytes. So remember that information, especially the size of this of our original model. So this time we will create an empty vertical window to load our XDB file. So go over here, and then we'll select empty. And now what we'll do is we'll go to load in our XDB file. We'll go to File, Data Input, and we'll select the format and go all the way down to the bottom and select XDB Import. We'll change this from, since it's a small file, we'll change it from parallel to local. And then we'll select Read, and then I'll go to my XDB folder and then select this. But before I load this, take a look at the size. You notice that now that we're looking at a 24.2 megabyte file size. So you'll see that its file size is greatly reduced. So I'll load that, and then I'll just select this subsection of functions up here that has my velocity, and then select OK. And I don't know if you guys just saw that, but the data just loaded. It loaded in very quickly. And so all of our surfaces for this are going to show up as boundary surfaces. So if I go over here and select boundary in this bottom menu, or this bottom object, and then I hit create, you'll see all of our boundary surfaces. So if I select all of the body and then select OK, we just had our body show up. And a quick trick is to click on this dataset button right here, because you'll notice, right, it's kind of like misaligned. So we can click on this button up here, that's dataset, and we can kind of correct the alignment a little bit. And I'll go to rotate and go to X, and then I'll select -90 to kind of set it on the same rotation as or the same orientation as the image below or above. Then I'll hit OK. And because what happens is when you create an empty window, this setting in the original is not preserved. So what I can do is to get this back to the same view above or the same angle, I can go and use another view restart. So I can open and right restart, select view, then I'll select the webinar, and now we have them aligned the same. And to continue to get them the same, I'll select my display type to smooth, and now we kind of have the same image. And now what I'll do is I'll create a second boundary surface. So I'll select create, and then this time I will select the cut plane, and then select OK. And once again, to get the settings similar to the other one, I'll change the coloring to scalar. Oops, sorry. Well, that's right. I want the display type to be constant, not smooth. So now that's aligned better. And then I will set the transparency to 37.5. And the scalar that we're looking at is velocity magnitude. And so that's selected. And now we have the same image created with the same color map at a small size that can be easily shared and viewed on a much smaller system. So with XDBs, you get a file format that has portability, speed, and efficiency without losing the fidelity of your visualizations. So this concludes our demonstration of introducing you to the basics of how to use FieldView. Hopefully you found value or learned new tricks from this presentation today. So now we'll hear from Gibson with some questions that were submitted.
Hi, Gerald. Yeah, so we've got one question here. How to import ANSYS Fluent and data and case files, which I believe is just one of the file formats we can import. Yeah.
But can you repeat that again? Sorry.
How to import ANSYS Fluent case and data files.
Okay, so I don't have an ANSYS file right off the bat, but you will go into file, and you'll hit data input, and then when you click on this format, you can see down here that we have all these formats that FieldView can read. And so if you did select like an ANSYS Fluent CFF file, then you should be able to have the option to read the grid data and read the results data. But yeah, I don't have an example to show you.
Yeah, no worries. And then let's see. Next question. How to change the background color from black to white. I believe it was under view and background.
Yeah, so yes, you can change your background view. You can go to view, and then you can go to background/environment. And so in this menu that I showed you how you can change the environment for reflections on the car, you can also change the background. So we can select white, blue, red, whatever color that we want. And you also have the option if you want to use like an image that you have saved on your computer, then you can select this box and select to use the image, and then you can select, hit select, and it will bring up the option, and then it will look for any type of images that you want to apply to the background.
Nice. Yeah, and then we've got one more question. If there's any other questions, feel free to message us at support@tecplot.com. One more question now. Is it possible to generate an arbitrary plane? I know you showed us computational or cutting planes, but an arbitrary cutting plane.
Yes, we can do that. So it is possible to create arbitrary slices, but you won't see them underneath the coordinate surfaces. We put them actually under the isosurfaces object. So if you click on isosurfaces, and what I'll do is, actually, let me go back to my coordinate surface. Let me hide this. And then I'll go back to my ISO surface, and what I'll do is I'll just delete the previous one so we can start fresh. So we put them in this ISO surface panel because to us, uh, it's really an ISO surface of a plane function. So in order to do that, we can select create. I think I already have. I think what's going to happen is it's going to load the Q criterion ISO surface. So let me load that really quick. And then, okay. So again, what we can do is we can select, to get to the arbitrary slice, we'll select cutting plane. So we'll select that down here. And we can use, here, this is what I'll do. I'll just change, let me close this so I can get a better view. I'm going to close this and I'm going to change this ISO surface. Okay, well, it's back. Okay, so I have that out of the way. So I'm going to go back to cutting plane and select that. And we can choose like a 3-point plane, or we can choose a normal vector, which uses 2 points. So I'll select a 3-point plane. And we can select 3 points by, I'll just control left click here for my first point, here for my second point, and then here for my third point. And then, so we have our 3 points selected, and then I'll select calculate. And this will kind of go through its calculation in the background. So what I can do is, as before, I can change, I think this, so we're looking at the cutter plane. I could change the scalar. So now we're looking at velocity magnitude. And then to make this look a little bit better, let's add some transparency so we can see some of the model behind it. And we can move this also to move the slice to a better location. And notice that we do have access to all cuts parallel to the cutting plane. And so, yeah, you can see that in this example. You can see me move it to different locations and how it looks. So yes, that's how you create an arbitrary slice.
All right. Yeah, that's all I've got for now.
Okay. So, in closing, yeah, I just want to say, thank you all for attending this webinar today. A reminder, if you want to rewatch this video, it will be available on YouTube and emailed to you as well. If you don't have access to FieldView, you can download a free 5-day trial at the provided link on this slide. Any questions that we didn't get to in this chat will be followed up with in the coming days. And as always, feel free to email Tecplot support@tecplot.com. We are happy to answer any questions you have on using FieldView or any of our other products. So I just want to say thanks again for attending.